Hello and welcome you all in this course of refrigeration and air conditioning. And the topic of lecture is psychrometry and psychrometric term. My name is Amit Tripathi. I am working as an assistant professor in the Department of Mechanical Engineering at AKGEC Engineering College, Ghaziabad. So, in today's lecture, I will discuss about the psychrometry. So, the term psychrometry, it is the branch of science. It is the branch of science which deals with the study of moist air. So, the branch which deals with the study of moist air is known as psychrometry. And as far as moist air is concerned, it is the mixture of dry air and water vapor, which is generally known as humidity. So the mixture of dry air and water vapor is known as moist air. And as far as dry air is concerned, it is the mixture of different gases, atmospheric gases like nitrogen, oxygen, carbon dioxide, helium, neon, argon, krypton, xenon, and dust, and so many other inert gases. So, dry air is the mixture of different gases like nitrogen, oxygen, and inert gases, dust also. So, in case of psychrometry, we deals with the study of, as I have discussed, moist air is the mixture of dry air and water vapor. And in psychrometry, we deals with the study of moist air. But we also know that in atmospheric air, there are some other gases like, as I have discussed in psychrometry, we deals with the study of moist air, but we considered that in moist air there is only dry air and water vapor. We neglect dust and other inert gases. So, as far as different psychrometric term is considered, different psychrometric terms are first dry air, second moist air, third saturated air, fourth degree of saturation, fifth specific humidity, which is also known as humidity ratio, sixth dry bulb temperature, seventh wet bulb temperature, eighth wet bulb depression, ninth relative humidity, 10th absolute humidity, So these are the different psychrometric terms which we will discuss one by one. So already I have discussed what is dry air, what is moist air. So we start with saturated air. It is the mixture of dry air and water vapor when the air has diffused maximum amount of water vapor into it. When air has diffused maximum amount of water vapor in dry air, then that condition of air is known as saturated air. Next, fourth is degree of saturation. Degree of saturation. Degree of saturation. It is the ratio of actual amount of water vapor present in air to the amount of water vapor present in saturated condition. So this is known as degree of saturation or ratio of saturation, or sometimes it is also percentage of saturation. So the ratio of actual amount of water vapor present in the air to the amount of water vapor present in saturated condition, that ratio is known as degree of saturation. Next, specific humidity, which is represented by W, and its unit is gram per kg of dry air. So it is the amount of water vapor present in 1 kg of dry air. So the amount of water vapor present in 1 kg of dry air is known as specific humidity. It is represented by W and its unit is gram per kg of dry air. Next psychrometric property is relative humidity. So represented by phi, or sometimes it is also written as RH simply. It is the ratio of actual amount of water vapor present in the given volume of moist air to the amount of water vapor present in the same volume of saturated air at same pressure and temperature. So this ratio is known as relative humidity, represented by phi. So according to definition, phi is equal to mass of water vapor present in given volume of moist air to the mass of water vapor in the same volume of saturated air. So this ratio is known as relative humidity phi. So let us consider for water vapor in actual condition, if we apply PV is equal to MRT for water vapor in actual condition, and water vapor in saturated condition, so PV is equal to MRT in saturated condition. So if we divide equation 1 by equation 2, then PV in actual condition divided by PV in saturated condition to MRT in actual condition divided by MRT in saturated condition. And we know that according to definition, volume is same. So water vapor in actual condition covered same volume as water vapor in saturated condition, and also temperatures are same. So temperature Ts and Tv are same according to definition. And we know that the value of gas constant for water vapor is equal to 0.461 kilojoule per kg Kelvin. And in saturated condition, if air is saturated, then the gas constant for water vapor Rs will also be equal to 0.461 because there is water molecules only. So the Rs will equal to Rv equal to Rs. So from here Rv, Rs will cancel out, temperature cancel out, volume will also cancel. So from here, and we know that from the definition, MB upon MS is equal to relative humidity phi. So finally we can write here phi is equal to MB upon MS is equal to PV upon PS. So this is all about the relative humidity. Next psychrometric term is absolute humidity. So it is the amount of water vapor present in unit volume of dry air. Amount of water vapor present in unit volume of dry air, and its unit is absolute humidity. Its unit is gram per meter cube of dry air. Gram per meter cube of dry air. So another psychrometric term is dry bulb temperature. In short, it may be written as DVT. or simply T suffix B. So it is the temperature of air recorded by a thermometer. It is the temperature of air recorded by a thermometer when its bulb is not affected by the moisture present in the air. When the bulb of thermometer is not affected by the moisture, then that air recorded by thermometer, that the temperature of that air recorded by a thermometer is known as dry bulb temperature. Next psychrometric term is wet bulb temperature, T suffix W. So according to a definition of wet bulb temperature, it is the temperature of air recorded by a thermometer. It is the temperature of air recorded by a thermometer when its bulb is surrounded by a wet cloth and exposed to the air. When its bulb is surrounded by a wet cloth and exposed to the air, then that temperature of air is known as wet bulb temperature. And next psychrometric term is wet bulb depression. In short, it is written as WBD, wet bulb depression. So it is the difference between dry bulb temperature and wet bulb temperature. So the difference between dry bulb temperature and wet bulb temperature is known as wet bulb depression. So this is all about the psychrometric properties. So on the basis of that, we will discuss different. This is all about the psychrometric term.